The next example is a problem that we discussed in the previous chapter, where we looked at cockpit systems, 35 of them, and each of them had a mean time before failure rate, and we used Bernoulli process to simulate failure of these 35 systems, and then ranked them from, well, we found the minimum time, the time at which the very first failure will occur, and then based on that we can decide um, how often we need to do maintenance. At the time, I mentioned that we were assuming the failure of these 35 systems will all be independent, and of course that is not realistic. Um, and so now we're going to look at how to incorporate dependencies among these different systems. So we're going to look at correlation this time, straight linear correlation. So here is the model that we had previously, where we have the mean time before failure, and then we didn't use the Bernoulli process. We used risk exponential to simulate how long will it take for the system to fail, and then we used the first failure will be the minimum of these time durations, and then uh, we looked at target. Okay, so how often? What is the probability that the first failure will occur within an hour, or within 2 hours, within 3 hours, within 4 hours, and so on? And we use the risk target for that. So this gives us the failure probability, because if the failure of the first system of the 35, the whole thing then fails. So this will then, if you're able to tolerate 5%, then you need to schedule maintenance every 5 hours, so that you have risk failure, or failure of risk no more than 5%. And of course, this is, and we have assumed that all of these are going to be independent, which is what we're going to now fix. So these are the inputs, right? So highlight these inputs, and we go to correlation, and then we do define correlation. Okay. Now, if you already had correlation, if you have data from before, and you can use the uh, Excel correlation, see, like if you go to data analysis and use correlation with the data, and that will generate your correlations for you. And we don't have the underlying data, so we have to define it. So we highlight like that, right? And then correlation, define correlation. Okay, so now the inputs, or the highlighted range is used as input, C2 to C36. Now click OK. All right, so now that sets up a blank template for the correlation. So right now all the correlations are 0, okay, which is the default case. Now we can add the rows and column labels, and then we select a place where to put the blank template. So when you do that, then the correlation will be associated with these inputs automatically. So here this was going to insert. Okay, so once you've selected the starting point, you click OK. That's going to insert the blank correlation, which is all zeros now, obviously, and then it is inserted the correlation matrix risk score mat into these inputs. So now we can go and enter the correlations we want, And suppose that we've already done that. Okay, so here it is, using the correlation command from Excel. Now you can copy paste these correlations. Okay. Okay, so I'm gonna, it's just the correlation, not the column and row labels. So now I have the correlations set up and associated with the inputs. Okay, now let's copy paste this as values so we can compare these probabilities. So we can go to home, paste values. All right. So these are the probabilities when we assume no correlation among these parts. Okay, so the rest of it is the same. Now we can run the correlation simulation and make sure that that's automatic, and we have fixed seed of 1. All right, so now simulate. Okay, so now we have the first failure, 10,000 simulations is okay, so 90% fall about here. But let's look at the table results, which is what we are interested in. So when we have when we incorporate the correlations, then our failure probabilities for the first failure at 900 is significantly different and gives you more accurate probabilities. So if 5 and you want like say no more than 3% failure probability, then you can schedule your maintenance every 10 hours.